In this article, there were several experiments conducted to show the effects of distracted driving and more specifically the effects it has on the driver. The experiments show how being distracted while driving can affect their brake performance time, pace clock errors, variability in lane keeping, and stoplight errors. Studies show distracted drivers have a slowed response time and are more likely to miss traffic events, such as a changing light or a stop sign. Most of these studies focus on performance decrements between different tasks or devices, such as handheld versus hands-free. The purpose of these studies is to help in legislative initiatives such as banning handheld cell phones while driving, and help with future innovations to make driving a safer environment. These studies have been beneficial in assessing the magnitude of different distractions, but they lack one important factor: the driver. Drivers may believe they can drive safely while engaging in distracting activities, but may not realize the effect on their actual performance. A study by Lesh and Hancock 2004 found that a prior rating of confidence in dealing with distracting tasks were not related to actual performance while distracted, meaning that drivers did not feel their performance was affected at all from what they had rated themselves simply because they were not even aware they had engaged in a performance decrement. This shows us that some drivers are not well calibrated with the distraction effects on their driving performance. The study expands on these results by evaluating how well calibrated drivers are regarding their performance while driving distracted. If you take a look at the study results, we can see that confidence ratings were significantly different in both age and gender groups. Horrey, Lish, and Garabet 2008 hypothesized that the willingness to engage in distracting activities while driving may be a function of the driver's perception of performance decrements. The goal of the study is to find support for the general hypothesis by examining the extent to which drivers were aware of the effects of distraction on driving performance. Understanding drivers' perception of distraction effects may help with the innovation of technology that will be less distracting. 40 drivers were recruited through a newspaper ad to drive on a controlled course. The drivers were split into two groups, 20 younger drivers and 20 older drivers. There were equal males and females in each group. The younger driver group consisted of drivers with ages between 18 and 34 years. The older driver group consisted of drivers of ages between 55 and 82 years old. Drivers were paid $20 an hour and an extra $20 for secondary tasks. A closed-loop, two-lane test track was used as a controlled environment for safety reasons. 5 pace clocks used for speed control tasking. There was a signalized intersection controlled by infrared sensors, and GPS tracking information was done via wireless modem. The controlled instrumental vehicle used was a 2002 Ford Windstar minivan equipped with several sensors and computers. A PC computer rack was mounted directly behind the driver to control and coordinate stimulus presentation, along with several cameras to capture interior and exterior viewpoints. A flip-down camera was mounted to the roof console, and a handheld numeric keypad was utilized for the experimenter to control the computers. An extra brake pedal was installed on the passenger side, and of course, a handheld device was used for the driver tasking. Our driving session began, participants were asked to fill out a questionnaire, which included demographic information. They were also asked to rate their confidence and to compare themselves to other drivers. Once completed, participants were allowed to do a practice loop to get used to the minivan and the course. It is important to note that the drivers were instructed that they could choose their own speed up to 30 miles per hour and that they needed to keep the vehicle in the center of the lane. Drivers were then asked to complete a pace clock task by accelerating and braking while approaching the pace clock. The goal was to pass the clock only when the arrow indicator was green, and they needed to avoid passing when the indicator was red, and were instructed not to come to a complete stop or accelerate over 30 miles per hour. For the traffic light tasking Drivers were instructed to bring the vehicle to a complete stop as fast as they could in order to stop before they reached the marked stop line. The signalized light changed randomly for unpredictability. The light changed only from red to green and green to red and varied between 4.5 and 5.5 seconds, which was controlled through GPS and sensors along the track. During the experimental blocks, drivers were instructed to drive 8 laps as a baseline, another 8 laps using a handheld device, and a final 8 laps using a hands-free device. During the 2 blocks, using hands-free and handheld devices, the drivers needed to perform a paced auditory serial addition task. As it included using numbers between 1 and 9 and showing the driver 2 numbers and asking them to add them all together and verbally express the answer. With each block, measures were taken to gauge lane keeping abilities, paced clock accuracy, and stoplight response time, and errors were recorded. Drivers were then given the opportunity in between blocks to complete a modified NASA TLX to rate their own performance on their taskings. The main goal of the study was to examine the extent to which drivers were calibrated to the effects of distraction on driving performance. The limitations that the study exhibited was data loss due to equipment and computer failure and differences in driving experience between the age groups. Those in the older age group have more experience driving than those in the younger group. The mean age of driving years of experience for the younger group was only 5.5 years and 4.7 years for the older age group. Results show that overestimating the impact of distractions while driving can have major consequences. There was one significant relationship with stoplight errors in which the drivers had poor stopping ability while distracted by a hands-free device. Results show a negative direction underlying poor calibration. Those who underestimated the effects of distracted driving were rated more prone to distractions, meaning their confidence in dealing with distractions or their ability to cope with distractions, but they did not appear to be overly confident in comparison to those who overestimated. Decrements due to distraction were considered consistent across all variables. There was no main effect on age/gender and performance rating, but there was a significant main effect on task and performance rating. Drivers that estimated the smallest performance decrements were actually exhibiting the largest one, thus supporting the hypothesis that willingness to engage in distracting activities may be a function of the driver's perception of distraction on performance decrements. It is important to understand that drivers may not even realize that their performance in driving is hindered when they are distracted. Performance feedback could help an overconfident driver, and identifying those factors that contribute to improved calibration is an area for further examination.